Hey guys, it's Mrs. Stevenson. These are the problems for this week due next Thursday, and I just wanted to give you a few tips on some of these. So this is going to be pretty short. So starting with number two, I know that you guys can all solve this. It's just a quadratic, but I just want to make sure everybody knows that you can always divide an entire equation, both sides, by the same number. So what you can do is you can divide out by the least or the greatest common divisor of all of these numbers. So what that will do is it will just basically reduce the quadratic and then make it easier to either factor or use the quadratic formula. All right, number five, if you're not familiar with this, what you want to do is just try to get all these numbers raised to the same power so that you can compare them. And in this case, because this is the lowest number and these are multiples of that number, what you want to do is try to rewrite A and B in terms of stuff raised to the fifth power. That way you can compare them. Okay, let me jump down to number 13. So you have the areas of 3 of the 6 sides. What is the volume? You do not want to try to figure out the measurements of the sides. What you want to do, let me drag a picture over here. So let's say here is our rectangular prism, and we just say we have 3 sides. Oops, that's not working. We'll call it A, B, and C. Okay, so we know that the surface areas then would be A times B is one of them, A times C is one of them, and B times C is one of them. Okay, we also know that the volume of the prism is just A times B times C. Okay, and then what I want you to investigate is what do you get? Because you know these 3 quantities, AB, AC, BC. What do you get if you multiply AB times AC times BC? Okay, so just multiply those variables together, see what you get, and then see how that compares to the volume. All right, so there's your hint on that one. Okay, I'm gonna erase this stuff and drag over a different picture. All right, so this one is regarding number 14. I'm just not sure if you guys have maybe ever heard of, like, say, a right skewed or a left skewed distribution before. Although juniors, if you've taken statistics, you should definitely know this. You know, you should be familiar with, say, a bell-shaped distribution. So, you know, most of the data is in here. There's some on this side, there's some on this side. Okay. Like an example would be people's heights are generally, you know, around here, but then some people are shorter and some people are taller. It forms a bell-shaped distribution. A right skewed distribution means you have more data on this side, but then you have a long tail out to the right with higher data values. Okay. So the way I think of it is the data leans to the left, therefore we call it right skewed. It's kind of the opposite. And then a left skewed distribution is the opposite. You have more data on the right, it leans to the right with a long tail out to the left. Okay, so in particular, if you're not sure how to answer this question, let me just give you an example data set. Say your data set is 1, 1, 1, 1, and 6. So this has a lot of data on the right, and then one data value way out here. I'm sorry, a lot of data on the left and one data value out here on the right. So calculate the average or the mean and the median and see which one is bigger. All right, gonna erase again and scooch down. Okay, number 17. The sum of two numbers is 31 and their positive difference is 6. What is the positive difference of their squares? So you've got two numbers, x and y. I'm going to come over to the side so I can write bigger. The two numbers, x and y. Now you could solve for x and y, but you don't have to, because what you really want is x squared minus y squared. All right, that is what the question asks for. So then just think about how this factors and then just solve for that instead of actually solving for x and y. All right, last comment briefly is on number 18. How many ordered pairs of positive integers solve this equation? So hopefully you recognize by now that that is a linear Diophantine equation. So you could use that method from the very start, or I think they did this deliberately. They picked a particular equation where it should actually be able to guess a particular solution, x and y, pretty easily just by inspection of the equation. So if you can do that, if you can see that particular solution, then just do that. And then you have your x0, your y0, and then you can write your general equation, and then you can figure out how many total solutions there are where they are positive. All right, that's all I got. So I'll see you guys later.